Welcome to 1.7 part 2 of writing proofs. Remember that part 1, you had watched that lesson. We had talked about various properties, definitions, etc. in order to build the foundation for actually writing proofs. We also went through proofs, and generally what a proof is, as well as a theorem. Now we're going to actually write proofs. We do a column proof, a 2-column proof, and a paragraph proof as an example. So yeah, let's dive right in. So again, the essential question is the same. How do we use deductive reasoning to prove a theorem? And we're going to be using it in this lesson. So this is just kind of review vocabulary. Notice that 2-column proof and paragraph proof are on there, just like before. We're going to actually do those. So when you write a proof, you only want to start with the given statement. There's usually some kind of statement either given in a diagram format or given as an actual statement. So you want to start with that when you're proof. So basically your starting point is the given statement. Your ending point is what you're trying to set out to prove. But in between those two, the beginning point and the finish line, you want to start working your way to that finish line by using what you know, such as properties, theorems, etc. Basically do it step by step, logically, in order to get to the final. Okay, so let's show how this works. We're going to prove the vertical angles theorem. Write a 2-column proof. Remember that the vertical angles theorem stated that if you're given two angles that are vertical, then that means that those two angles are congruent. We want to prove that. So the starting point is, well, given that the two angles are vertical, right? And what we want to prove is that they're congruent. A 2-column proof and set this up. First off, we start with the given statement. Remember, with a 2-column proof, you have this statement on the left side, reasons on the right side. So your first statement is always going to be your given statement. Okay, so given statement, angle 1 and angle 2 are vertical. And the reason for that, you just state that it's given. Okay, that's a given. So you're always going to have that first line being the reason is given based off of the statement. Okay. And so now we know that from this diagram, angle 1 and angle 3 is angle 1 and 3 form supplementary angles, which means that they add up to 180 degrees. Just from this diagram, you can see that angle 1 and 3 are definitely supplementary. And so, which means that they're supplementary angles. And then angle 2 and angle 3 are also supplementary angles. So we have angle 1 and 3 are supplementary, but angle 2 and 3 are also supplementary. So we're going to use those statements to our advantage. So we're going to say, well, because they're supplementary, that means that they add up to 180. So that means the measure of angle 1 and 3 adds up to 180. Angle 2 and 3 add up to 180. The reason is that they're supplementary angles. So now we're going to say, well, because they're both equal to 180 degrees, well, then that means that by the transitive property, remember the transitive property states that if A equals B and B equals C, then that means that A has to equal C. And so we're saying that let's say that this is A equals 180 and B also equals 180. And that means that they have to be equal to each other, which means that, so in this equals B, so B is 180 in this case. So either way, so if they're equal to the same thing, we'll just set them equal, right? So in this case, we have a transitive property. Now that we know they're equal to each other, we're going to go ahead and get rid of that 3, the measure of angle 3, because to cancel it out, the way we can cancel it out is by subtracting it on both sides. And so we end up using the subtraction property of equality. We know that the measure of angle 1 is equal to the measure of angle 2. If the measures are the same, that means that the two angles have the definition of congruence. The definition of congruence angles, that if the measures are the same, that means the angles. See how we logically went from one step to the next, and we ended up proving what we wanted to prove, which is that angle 1 is congruent. That is it for the two-column proof. Now let's do a two-column proof for this example, and we'll call this example 2. So for this two-column proof, we want to figure out, well, we're given BD, ray BD, bisects angle CB. We're looking at this ray bisects this angle. Bisects means cuts it in half. Okay, so, and we want to prove that angle ABD is congruent to. Okay, so let's go ahead and remember, we're going to start with the given here. Okay, so what are we given? We're given that BD bisects CB, angle. Okay, so that's the. And then from there, we had to figure out, okay, what do we do next? Well, if it bisects CB, right? If it cuts it in half, then that means that the top angle is equal to this bottom angle, right? So that's going to be our next logical step. We're going to go ahead and say that, you know, the top angle in red is equal to the bottom angle in red. And also, we also know that I'll highlight this. We also know that this green lines forms vertical angles. We know that the green intersecting lines have vertical angles given by the blue. Vertical angles that are in blue in this diagram are congruent. We're going to use those two pieces of information to help us out here. So logically, we'll say, okay, well, because it bisects, we know that the top red is equal to the bottom red. Well, the top red is CBD, bottom red is DBE. We know they have to be because that is the definition of a bisector. It cuts it in half, right? Right. So now using the blue vertical angles, well, we know that the measure of CB, oh, I'm sorry, using, let's go ahead. We're not there quite yet with the blue. So we're still going to be using this. So now that we know that they're congruent, that also means that the measures are the same. And so we know that the measures are the same, both, for example, 100 degrees or 150. And that's the definition of angles. Congruent, then that means they're the same. And so now let's go ahead and use vertical angles here. We know that those blue ones are vertical, and so have to be congruent. Okay, so congruent, and the reason is that they're vertical. We're going to use those statements in order to prove stuff. But now, okay, so since we that they're congruent, and well, then that means that the measures have to be the same. Okay, because the vertical angles are congruent or have the same measure. That's the vertical angle postulate. So again, you were kind of going baby steps. You know, if they're congruent, that means they're the same, and so on. Then now we're going to put together. So we know that ABD, right? So ABD right here is the way you get the green angle is by getting the red angle and adding this blue angle right here. Okay, so the red plus the blue gives you the green. That's what this statement is here. That this green is equal to, I'll use red here, equal to CBD, red one, plus ABC, blue one. And that's known as the angle postulate. Two angles add up to a big angle. All right, similarly, if we want to get FBE, well, then we have to add the red and the blue on the bottom. Okay, so we want to get FBD. We're going to take the red DBE or EBD. They're both the same. That's in red. And we're going to add it to FBE. All right, and that's the angle addition postulate. And so now we say, well, we know that FBD. Okay, so we know that the measure of FBD is this guy, right? And we know that FBE is equal to ABC. And so we can say that, well, since we know that it's equal to ABC, we can substitute that here, okay? That's the substitution property. So basically, we replaced that with ABC. And so that's known as a substitution property. So this guy got replaced, and he is now ABC because of this statement right here. All right, and so now we know, well, we know that ABC plus CBD equal to, if we look at this statement right here, well, that's equal to ABD. We can use another, you can call it a substitution, but you can also call it a transitive property. If these two are equal, well, then they have to be equal to ABD. So you can also call it a transitive property. And so ABD has to equal FBD. Measures are equal, then we convert them back to congruence. That means that they have to be congruent, and they're congruent because that's the definition of. Okay, so this is an example of proofs, and some proofs are harder to do than others. This is like multi-step proof, right? This is almost 10 steps. Some proofs are going to be easier than others, as you see. We covered a couple of examples of a two-column proof. Now, eventually, we're going to go ahead and we're going to eventually do a paragraph proof. But before we get to that, we're going to introduce a couple of theorems. So we're going to talk about first the congruent supplements and the congruent complements theorem. Okay, remember congruent means that they're the same measure, and supplement means they add up to 180. So if two angles add up to 180, two angles that are supplementary to congruent angles, then that. So let's look at this example. So looking at this picture. So angle 1 and angle 2 here add up to 180. Right? So these are supplementary. We also know that angle 3 and angle 2 are also supplementary, right? So that's basically that's saying if two angles, these two angles, 1 and 3, they're both supplementary to 2. Well, if they're both supplementary to the same angle, which is 2, then that means angle 1 has to be equal to angle 3, or congruent. That's basically what the theorem states. Okay, so 1 and 2 equal to 180, and 3 and 2 equal to 180. And that means that 1 is equal to 3. 1 is equal. Same thing for the congruent complements theorem. If you look at the diagram, well, angle 1 is complementary to angle 2, but angle 3 is also complementary to angle 2. And so that means angle 1 has to equal angle 3. That's basically what the theorem states. So now let's actually prove one of those theorems. So let's prove the congruent supplement with a paragraph proof. Okay, so remember that the congruent theorem states that, well, basically, if you have angle 1 and angle 2 are supplementary, angle 2 and angle 3 are also supplementary, well, then angle 1 has to be congruent to angle 3. Okay, so this is a given statement. We want to prove that that's the case. Okay, so remember, in a proof, you want to start with the given. What's the given statement, guys? So suppose that angle 1, I'm not going to have enough room here, so I'll put it on top here. Suppose that angle 1, angle 2 are supplementary. And 2 and angle 3 are supplementary. So suppose that that's true. Basically the given statement. And that's true. Well, by the definition of supplementary angles, next logical step is to talk about supplementary angles. So then by the definition of supplementary angles, And that means that, well, means that they add to 180, right? So that means that the measure of 1 and the measure of 2 have to add up to 180. Same thing for 2 and 3. If 2 and 3 are supplementary, then that means the measure of 2 and the measure of 3 add up to 180 by that definition. Now, both of these angles are equal to 180, right? So since both angles, both sums equal 180, we can set them equal to each other by the transitive property. So we can say that the measure of angle 1 and the measure of angle 2 has to be the same as the measure of angle 2 and the measure of angle 3 because they're both equal to 180. And 180 equals. Now we can solve this. We can basically get rid of the measure of angle 2 by subtracting it. So we're going to subtract the measure of angle 2 on both sides. And so in that case, these kind of cancel, right? Cancel, well then you're left with angle 1 equals angle 3. So we have the measure of angle 1 is equal to the measure of angle 3. Well then by the definition of angles, that 1 has to be congruent to 3, right? So by the definition of congruent angles, angle 1 has to be congruent to angle 3. So you can kind of see we're using a lot of the definitions and postulates that we talked about in the previous thing. We're talking about supplementary angles. We're talking about them adding up to 180. We're talking about congruence. We're talking about all that stuff that we're going to need. So these are the building blocks, the tools to be able to do proofs. And so we set out to prove what we wanted to prove. We're done with this proof. That's an example of a paragraph proof. We can do this as a 2-column proof by listing out steps instead of writing it as a paragraph. All right, so let's look at other theorems. So another theorem states that all right angles are congruent. So any right angle that you see is equivalent to another right angle that you see. And some of these are kind of obvious. You can go about proving some of these. If two angles are congruent and supplementary, that means they both have to be a right angle. So for example, in this case, angle 1 and angle 2 are the same, right? We know that they're the same. And we know that they add up to 180 degrees, right? So if those two things are true, that means they have to be 90 degrees because 90 plus 90 is 180 and 90 is equal to 90. There's no other way to do it, right? We have the case where it was 30 and 150. 30 is not the same thing as 150. Right. That is another theorem. Another theorem, the linear pairs theorem. So if angle 1 and angle 2 form a linear pair, which they do in this example, add up to 180. Linear pairs theorem. Let's write a 2-column proof for this example. So we're given that the measure of angle 1 equals the measure of angle 2. We're also given that angle 1 is 105 degrees. What is the measure of angle 3? Or, well, we know that it says it's 75, but we want to prove that it's 75 degrees. Okay, so let's go set out to prove this. Do a 2-column proof. Remember, let's start with the given statements, right? These are my given statements. Well, angle 1 is equal to angle 2, the measures, that's given. And the measure of angle 1 is 100, that's given. All right, so then what we're going to do is, well, look at the angles. Well, we know that angle 1 is equal to angle 2, but we also know that angle 1 is 105, which means that angle 2 has to be equal to 105. If you kind of cancel these out, well, they have to be equal to each other, right? That's the transitive property. Another theorem that we want to use is, or another definition is the fact that, well, 2 and 3 here are actually a linear pair because they add up to 180. So we know that they're a linear pair, and the reason is that, well, that's the definition of a linear pair. Their linear pair, remember, is formed by intersecting angles, right? Or intersecting lines, I'm sorry. So because we have intersecting lines, well, angle 2 and 3 have to form a linear pair. Well, then we're going to use the linear pairs theorem, and we know that they have to add up to 180. They add up to 180. And so 2 and 3 for 180. And well, we know that angle 2 is equal to 105. So we're going to replace angle 2 with 105. And you can guess what we're going to do next. We're going to solve for the measure of angle 3. We're going to subtract 105 on both sides. Subtraction property, right? So subtract 105 on both sides. Subtraction property. So angle 3 is equal to the measure. We proved what we wanted to prove. All right, guys, that is it for the lesson. So we talked about 2-column proofs, paragraph proofs, and we actually wrote those proofs. So remember that in a proof, you want to start with the given, and you want to end with what you want to prove, and all in between is going to be statements that basically build up to that final proof. You build it up using what you know, basically using the building blocks, using postulates, definitions, that kind of stuff. And that's known as using the reasoning. All right, guys, I hope you learned something from this. I'll see you in the next one.